So in this video, we're going to cover the exponent rules and properties. There are different exponent rules, and the names are going to be on the first column. The rule itself is going to be in the middle column, and the example will be on the right column. You need to make sure that you are going to be copying the example step by step. First, we're going to start with the product rules. They have the same base, different exponents. So when you have the same base and different exponents, as you can see from the example, you have a, but then you have an exponent n and an exponent m. So when you have the same base but different exponents, the only thing you need to do is keep the same base and add the two exponents. Let's work on an example. We have 4 to the second power times 4 to the fifth power. Okay, if we follow the example, it says that if they have the same base, we add the exponents. Yes, a base of 4, a base of 4, the exponent is 2 and 5. The only thing we need to do is add the exponents. So this is going to be equal to 4 to the second power plus fifth power, and this is going to give you 4 to the seventh power. This is all the work you need to be showing for all the problems that you are going to be working on. Next one, we are going to be once again working with product rule, but now you have different bases but the same exponent. So these are the conditions. This is a different base. You have a base that is a and a base that is b, but look, it says same exponent. So you have an n and an n. That is your exponent. And remember, these variables represent numbers. So let's say you have a base 2 to the fourth power times a base of 5 to the fourth power. Now what you need to do is you're going to multiply the bases and keep the exponent. So you're going to write it as parentheses 2 times 5 raised to the fourth power. And now you can actually work this out. 2 times 5 will give you 10. So you write it as 10 to the fourth power. And once again, we are only practicing to leave it in exponent form. We actually don't want you to give me the solution. We don't want you to solve at the moment. Now, we are going to be doing quotient rule. Remember, quotient is the answer to a division problem. So you're going to see the division sign. So in this case, we have the same base, different exponents. So again, we're dealing with the same base and different exponents. And we are going to be doing base 4. So we have 4 to the fifth power divided by 4 to the second power. And you can see right here that you have the same base, different exponents, and you need to subtract the exponents. So you're going to rewrite it as 4 to the fifth power minus 2 and that will give you 4 to the third power. Okay, the number that we used, the minus 2, came from being in the lower half, being the denominator. Now we're going to be working with different bases but the same exponent. So we have different bases. So for example, we are dealing with 4 to the third power divided by 2 to the third power. Then the only thing we need to do is rewrite this as 4 divided by 2 to the third power, or cube. And you know that 4 divided by 2 gives you 2. So you have 2 to the third power. And that will be your answer. Now we're going to be working with power rule, or also known as product of powers. That is how your book calls it. So we have a base raised to a power, and now that base with that exponent is also being raised to another power. So when you have one base and two different exponents, then you're going to be multiplying the exponents. For example, if you have 4 to the second power to the fifth power, then what you need to do here is multiply the exponent so we keep the same base. So 4 stays the same, and now you multiply 2 times 5, and that will give you 4 to the 10th power. Okay, I know that you could actually just see the 2 and the 5 and know that you need to multiply, and that's how you get 10. But I actually want you to show me every single step, because if you get confused or something goes wrong, I can actually tell you how to fix that error. Now let's move to the next one. It says negative exponents. So when you have a negative exponent similar to this, b to the negative n, then you're going to write this as a fraction. So you're going to write it as a reciprocal, and you change the sign of the exponent. So from being negative, it becomes positive. Also, if you have 1 divided by b to the n power, you could also work backwards and actually rewrite this as the reciprocal with a negative exponent. So let's see an example. If you have 4 to the negative second power, you can actually rewrite this as 1 over 4 to the positive second power. And that is exactly the same thing. So sometimes you're going to want to change a number with a negative exponent into a fraction, and sometimes you want to change a fraction into a number with a negative exponent. So make sure that you know when to use it. Now we're going to be working on 2 more, which is a zero rule. First, we're going to see when you have 0 as an exponent, so b, which is a variable representing a base, to the 0 power gives you 1. Okay, so any number raised to the 0 power gives you 1. Not 0 gives you 1. We actually did a proof for it that I expect you to copy at the end of this video. So if you have 4 to the 0 power, you get 1. 8 to the 0 power, you get 1. 100 to the 0 power, you get 1. Now, I want you to see the next one. It says 0 to the nth power. So we actually have 0 as a base, but then you have an n. And we already covered that you cannot have 0 in the denominator. That's why it says for n, your number, your exponent, must be greater than 0. That way you can never get a fraction. So for example, if you get 0 to the second power, you get 0. But if you get 0 to the 0.1, you still get 0. But as you can tell, 0.1 is still larger than 0. So when your exponent is positive and you have a 0 base, your answer is going to be 0. Now your worksheet should look exactly like this, using the same numbers. And please, I want you to highlight. I want you to highlight with one color, same base, different exponents, and you're going to do it for this one. And then you're going to do it again for the quotient rules, same base, different exponents. And then you're going to use a different highlighter to highlight different base, same exponent, different base, same exponent. Now on your notebook, you're going to write practice problems and you are going to put today's date. You are going to be working on 5 problems and then you will be checking the answers. Okay, this is a more complex problem. So the first thing that we're going to be doing is we're going to break it down into 2 parts. We are going to be dealing with the top part first, the numerator, and then we deal with the denominator. So you need to be referring to your properties worksheet to be able to do this. And you are doing these problems in your composition book. So you have 5 to the third power times 6 to the third power, and all of it is divided by 2 to the third power. Okay, so let's deal with the numerator first. So you have 5 to the third power times 6 to the third power, and according to the product rule, we are able to multiply different bases that have the same exponent. So we can rewrite this as 5 times 6, and all of it is going to be to the third power divided by 2 to the third power. Okay, try to work on it for a couple seconds and see if you can come up with the answer. Then I'll walk you step by step. So now I'll finish it up. So you have 5 times 6 gives you 30 to the third power, and then you're going to divide this by 2 to the third power. And according to the quotient rule, I can actually rewrite this as 30 divided by 2 and everything to the third power. 30 divided by 2 gives you 15 to the third power. Now we can stop right there. Now finish the other 4 problems in your notebook. I will be providing you the answers. You must show all your steps